So if you are a regular viewer of the channel, you will remember a series of videos from last year where we helped EKWB develop a direct die CPU block for custom loop cooling. Since then, EK has launched the world's first AIO designed for cooling delidded Intel LGA1700 CPUs. So in this video, we're taking a look at the EK-Nucleus AIO CR360 direct die cooler and finding out if it can tame the Intel Core i9-14900KS. So if you are interested in direct die CPU cooling, you've probably heard of the EK-Nucleus AIO CR360 direct die cooler. It is available to purchase now in the UK. You can pick it up from places like OSA UK and it's priced at $199.99. You can also buy it from EKWB directly from their own web store. It's priced about €170, but you've got to add shipping on top of that. One thing that's not included with the direct die AIO is a delid tool. You'll obviously need a delid tool to delid your CPU for direct die cooling. You can pick up the EK delid tool from Overclockers UK and it's priced at about £70. I would have liked to have seen that included, or at least a version of the cooler that includes the delid tool, because you're not going to be direct die cooling without delidding, but it is available to purchase separately. The EK-Nucleus AIO CR360 direct die features an exclusive direct die cooling engine with a nickel-plated cold plate designed specifically for Intel socket LGA1700 delidded CPUs, which is the first ever AIO of its kind. It has a unique rotatable pump block top cover made from brushed aluminium featuring a skull emblem, with an alternative plain brushed aluminium cover with RGB lighting ring included in the box. The included EK loop daisy chainable 120mm fans are equipped with digital ARGB lighting, high static pressure and PWM speed control. It's equipped with a 360mm aluminium radiator with brushed aluminium side panel trims, reinforced sleeved rubber tubing and fittings hidden behind a black aesthetic cover. So this is the EK-Nucleus AIO 360 direct die. From the outside you'd think it looks just the same or similar to any other EK-Nucleus AIO. It looks pretty ordinary. The only real difference is the change in the cooling engine and the cold plate, which is designed specifically for Intel LGA1700 delidded CPUs. It uses the same aluminium radiator, 27mm thick, and it has these brushed aluminium panels and then this plastic cover on the end of the radiator. It's just an aesthetic cover to hide the fittings. The tubing is approximately 400mm long. It's covered with a braided sleeving. Looks premium. And on the CPU block side, you have these rotary 90-degree fittings, and these also have brushed aluminium trim accents on them. On top of the CPU block, it comes with this skull emblem. This is a brushed aluminium trim cover and it is removable, so you can take this off and you can change the orientation of it. So depending on how the block is installed to the motherboard, you can change the orientation of this top cover to suit how it's installed, to make sure it's always facing the correct way up. This has some RGB lighting. There's an RGB ring and the EK logo is also illuminated in RGB. If you don't like the look of that skull cover, included in the box is just a plain brushed aluminium top cover, and again that is also rotatable, and it also has the ring of ARGB lighting and the ARGB illuminated EK logo. Fans don't come pre-assembled to the radiator. I've just attached them so you can see how they look. They are daisy chainable fans, so they have these micro fit connectors and just daisy chain to each other, and then the end comes with an extension lead that splits the PWM signal and the ARGB header to a standard 4-pin PWM header and a standard 3-pin 5-volt ARGB motherboard header. The fans have a maximum airflow of 72 cubic feet per minute, maximum air pressure of 2.7mm H2O, and a maximum noise output of 36 decibels. EK loop fans are equipped with a fluid dynamic bearing and have 4-pin PWM speed control. So the main change between the original or the standard EK-Nucleus and the direct die one, it's all on the cooling engine at the base of the CPU block. So here is a nickel plated copper cold plate with micro fins. The original Nucleus was just bare copper, and you can see in the center of it is this raised boss section, which is the area that's needed to make contact with a delidded CPU. So this makes direct contact with the CPU die once you have removed the IHS. That's the reason for this raised boss section. This takes up the difference in the height between a lidded CPU and a delidded CPU. At the pump, we've got standard connections. So for speed control of the pump, it's a standard 4-pin PWM header, and then ARGB lighting is also controlled by a standard 3-pin 5-volt ARGB header. As I said earlier, you don't get a delid tool included with the cooler, but you do get some accessories included. You get some thermal grizzly, conductor or liquid metal. Obviously you'll need to use liquid metal between the CPU block and the die of the CPU. You also get this box of accessories. So inside here, it's very similar to what you got with the original Nucleus, apart from you only get Intel standoffs, thumb screws for the standoffs. You get all the installation screws. This is a handy little tool as well that you get with it to install the standoffs, to tighten the standoffs up. This is the breakaway cable. So on one end, there's a micro fit connector that connects to the end of the fans, and then that splits off to a 4-pin PWM and a 3-pin 5-volt ARGB header. And then inside this other box, there's all the mounting hardware. So that's the upper mounting bracket, and that screws directly to the base of the cooler. And then this is a 2-piece contact frame. So this is the back plate, and then this is the upper part of the contact frame, because obviously when you delid the CPU, remove the IHS, you can't use the standard Intel ILM to clamp the CPU down into the socket. So EK provides its own contact frame to ensure that the CPU is seated correctly in the socket and it's getting the correct amount of pressure. So that's the cooler and everything that's included. I'll be testing the cooler on the new Intel Core i9-14900KS CPU, just recently launched. I expect somewhere near 400 watts package power with this CPU, so it'll be a great test for this cooler. I am using the standard EK-Nucleus to test the thermals before delidding, and we'll compare the difference between the standard Nucleus and the direct die Nucleus once the CPU has been delidded. So I originally planned to use the Gigabyte Z790 Aorus Master for this test, but I had some issues with BIOS defaults loaded. Running a single Cinebench test would cause the system to crash and even sometimes cause a blue screen error. I was able to use the Aorus Master and set the frequency and voltage manually, but in the end I switched to the MSI Z790 Ace Max. Stability with BIOS defaults loaded was much more improved because there was a beta BIOS recently uploaded by MSI that supports the 14900KS. So the 14900KS is installed with a Thermalright contact frame, and I'm using the standard EK-Nucleus, the non-direct die version to begin with. So in the MSI BIOS, I've got the BIOS defaults loaded and the power limit profile for water cooling. If we run a Cinebench R23 benchmark, just a single run, the CPU fans ramp up quite quickly and the CPU temperature exceeds 90 degrees also very quickly. But we get a Cinebench score of around 42,000 points. If we keep repeating that test, the score drops and eventually the system shuts down due to instability. I think MSI still has some work to do on that beta BIOS. So I then switched to manually adjusting the frequency and voltage. All the P cores are at 5.8 gigahertz. XMP is enabled in the BIOS, and the V core is set at 1.38 volts with level 5 load line calibration. If I run a Cinebench R23 30-minute loop test to test for stability, CPU temperature reaches 100 degrees quite quickly. CPU package power is at around 400 watts. V core voltage with level 5 load line calibration drops to around about 1.36 volts. System is stable, but the CPU is very hot, quickly reaches 100 degrees and stays at that temperature until the end of the test.
If you're looking for a new chair, then you should definitely check out Booley's. I'm currently sat on their Ninja Pro gaming chair, which is one of 3 models from their gaming series alongside the Elite and the Master. So if you're looking for something new to stick in your setup that you can sit on and game and work, then I recommend definitely checking out boolies.co.uk.
So with the stock CPU with the IHS still on, not delidded, and using the standard EK-Nucleus 360, CPU temperature quite quickly reaches 100 degrees in the Cinebench R23 30-minute run. Now we know what the standard Nucleus is capable of with the 14900KS with its lid on. Let's delid the CPU and see what the direct die Nucleus can do. So because the EK delid tool is completely a metal tool, it's recommended that you put the CPU into the tool and then put the tool in the oven at 70 degrees C for about 20 minutes to heat up the indium solder and to minimize the risk of doing any damage to your CPU. EK's Joe Roby has a brilliant video with a step-by-step instructions showing you how to do it. I'd recommend watching that video if you want to minimize risk of damage to your CPU. However, I'll be using a hot air soldering station to warm up the CPU and the delid tool before trying to remove the IHS. CPU is delidded, it's cleaned up nicely, there doesn't look like there's any physical damage to the CPU visible. Let's get some liquid metal on this and take a look at the installation of the Nucleus direct die. I've installed the Nucleus backplate, and these are the standoffs, these screw into the backplate directly. Now I need to remove the original Intel ILM. I put the delidded CPU back in the socket just to stop anything dropping in there, causing any damage to the pins. Now the top part of the contact frame sits on top of the CPU. We install the screws for that. You want to try to keep the pressure as even as possible on these when you tighten them up. And apply some conductor, not liquid metal, to the CPU. Make sure you cover the entire CPU die with the liquid metal. Try to get it spread as evenly as possible. Also apply a thin layer of liquid metal to the cooler's base plate. Tighten the thumb screws down equally by hand at first. It's quite important that you get these tightened as equally as possible. And then just finish tightening up with the screwdriver. Connect up the pump power cable to a fan pump header on the motherboard and connect up the fan power to the CPU fan header. If you want to use the RGB lighting, link the two RGB cables together, then connect it to the 5V 3-pin RGB header on the motherboard. Once you've mounted your radiator in the case, that's the installation complete. So now with the CPU delidded and the direct die EK-Nucleus AIO installed, when I run a Cinebench R23 benchmark with the BIOS defaults loaded, the scores are similar because the CPU frequency is unchanged, but now it's a score in the high 42,000 range. However, the peak CPU temperature now is approximately 20 degrees C lower at around 72 degrees C. If I run the Cinebench R23 stability test for 30 minutes with the CPU frequency at 5.8 GHz on the P cores and V core at 1.38 volts like it was previously. Again, the peak temperature is around 20 degrees C lower than it was when using the standard EK-Nucleus on an unmodified CPU. This means that now I can run a higher all P core frequency, which was impossible with the stock CPU IHS. Previously with the unmodified CPU, if I tried to run 5.9 GHz P core and 1.42 volts V core, the CPU would very quickly overheat and the system would shut down to protect the CPU. But now I can run back-to-back Cinebench runs and the CPU temperature stabilizes at around 90 to 92 degrees C, which is a great improvement. So my conclusion to all this would be, if you're thinking of picking up a 14900KS, then forget about even trying to run default BIOS settings, because you're going to either run into some stability issues or temperature issues one way or another. It's not going to be a good experience, I don't think, unless you're happy with setting your own frequency and voltages. You can get the CPU to run pretty nicely. I'd also forget trying to use a mainstream traditional style cooler or AIO with it and just pick up one of these direct die EK-Nucleus coolers. There is a risk of damaging the CPU when you're delidding it, but if you follow the installation instructions, watch the guide from Joe Roby from EK on how to delid the CPU, the risks are minimal. It still is potential you could damage the CPU, but you're lowering those risks if you do it correctly. The cooler's really easy to install once the CPU is delidded. It's just like installing any other AIO cooler. Price is reasonable. It's a lot cheaper to pick up one of these than building a full custom loop and using one of the direct die custom loop CPU blocks there are on the market. It's a good looking cooler, and as we've seen from the experiments we've done by delidding the CPU, it works absolutely brilliantly. Dropping the CPU temperature by about 20 degrees C, you can't argue with that. You're not going to get anywhere near those kind of temperatures, and higher frequencies possible by using a standard EK-Nucleus or other standard AIO coolers or an air cooler. If you want to delid a CPU, buy the 14900KS and pick up the EK-Nucleus AIO because it's an absolutely great product. So that's the EK-Nucleus AIO CR360 direct die CPU cooler. Let me know what you think of the cooler and the CPU and the delidding experience in the comment section. If you've enjoyed watching this video, don't forget to give it a thumbs up. Subscribe to the Kit Guru channel if you've not already done so. If you enjoy what we do here at Kit Guru and you want to help support us, you can always head over to the store, pick up some merch, or you could even subscribe to our Patreon. And as always, to catch up on all the in-depth technical reviews, head over to the website.